Hi there, I'm Clifford Bates, and welcome once again to this is basically basic methods for political science, where I'm looking at Stephen Van Ever's book Guide to Methods of Political Science, kind of giving the introduction to it. We're looking at basically the books chapters 1, 2, and 3 only. There's other chapters that could go into, but I'm not they're more technical and about writing, and I don't really think that they're useful for what I want to do to introduce people things to hear. I can maybe in the future plan to have a writing thing. I'm not a super duper guy in writing, but just basic writing stuff and like this, and maybe some a video about notes. People say, "Well, I want you to just give more video. You need to be more interactive in your video. You need to have like windscreens." That's the problem with writing things. I'm not that good with things like you. I need to use what do you call it? Things like whiteboard or something like that, and pen and things like this. And yeah, whatever. It's whatever. I'm sorry, if I'm not that great on these things, but yeah. So let's go dealing with this. We're going to be continuing today at Whenever, looking at chapter 2. They're looking at the testing theories. Okay, this is over here. So let's go over here. We're going to flip over soon. He says testing theories with case studies. Right? Again. Case studies can serve five main purposes. So these are the five main purposes of case studies. Five purposes. 1, testing theories. 2, creating theories. 3, identifying antecedent conditions. Not verifying them, identifying them. 4, testing the importance of these antecedent conditions. And fifth, explaining cases of intrinsic importance, right? These purposes overlap in several, such as explaining cases and creating theories and testing theories, right? And identifying and testing antecedent conditions can often and should be pursued simultaneously, the argument is. For the another typology of case study thought, see Leiphardt's thing, comparative politics, and like that. He distinguishes between 6 types of case studies: a theoretical, interpretive, hypothesis generating, theory confirming, and theory infirming, and deviant, right? 6 types, right? And deviant. 5 of Leiphardt's categories overlap with 3 of mine. His study types 4 and 5 are types of theory testing studies. His type 2 is a case explaining study. His type 3 and 6 are types of theory making study. Leiphardt's first study type is descriptive history. A study type I do not consider here, right? Descriptive history, right? He omits antecedent condition identifying and conditions testing studies, which I consider later in this chapter, right? These things. So therefore, this is how he differs from Leiphard. So those are the first the first 4 purposes are again uh, 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 testing theories, identifying theories, creating testing theories, creating theories, identifying theories, and testing antecedent conditions. Right, the first 4 are similar in their logic and are realized using the same basic methods. Right, although each proposed methods of its own discussion. Readers familiar with this material may wish to skip this section explaining case studies after reading this one, right? Right, this theory. But case studies offer 3 formats for testing theories, right? They offer 3 formats: controlled comparison, congruence procedures, and process testing. These are the 3 formats for testing. Okay, controlled comparisons, congruence procedures, process tracing. Okay, controlled comparisons use comparative observations across cases to test theory. So this is the first thing. Controlled comparisons use comparative observations across cases to test theories. Congruence procedures are of 2 types, with one using comparative observations across cases to test theories, the other using observations within case. Process tracing, so that's the second one. So therefore, the second thing has 2 types, right? 2 varieties, across and within, right? And process tracing tests theories using observations within case, right? Congruence procedures and process traces are stronger test methods than controlled comparisons. Okay, so therefore, congruence procedures and process are stronger than that. All three are also used to create theories and infer and test antecedent conditions. So, controlled comparisons are weaker than congruence and process tracing. Okay? In each testing format, the same three steps should be followed. So, state the theory. So, no matter what you do, either going to be compared comparisons, congruence procedures, or this. This is each testing format. These steps should be followed. State the theory. State expectations of what should be observed in the case if the theory is valid, and what we should observe if it's false. So therefore, to explain expectations, right? What should we find if it's valid? What should we find if it's false, right? State things. So first, state the theory. What the theory clearly state. I would say clearly state the theory, right? Clearly state the expectations. That is, what should we find if the theory is valid? What should we find if it's false? Observe if it's false. Either observe or find. Okay, in that sense. And three, explore the case or cases looking for congruence or incongruence between expectations and observation. So explore the case or cases looking for congruence or incongruity. It means things that have agreement or disagreement between expectations and observations. Now, we're going to be looking at first controlled comparison, right? Controlled comparisons. And controlled comparisons, okay, first of all, controlled comparison 19, he says McGraw and this, and case studies theories, and Collier's case studies methods, and these are the examples of this. In controlled comparisons, the investigator explores paired observations in two or more cases, asking if values on the pairs are congruent or incongruent with the theory's test prediction. So therefore, this is saying what? It's saying look at two things and look at you look at two more cases and see if the values on if values on pairs of the things you're looking at explore pairs observations in two or more cases and asked if the pairs are congruent or incongruent with the test theory's predictions. They agree with it, sure. For example, if the values of the independent variable are higher in case A than case B, values on the independent variable should also be higher in case A than case B. If values on the DV are in fact higher in case A than case B, the theory passes the test. If the theories are much higher, this indicates the theory has large importance. That variance on the value of the independent variable, IV, right? IV independent variable, DV dependent variable, will cause large variance in the value of the dependent variable, DV. If they are a little higher, then the test again is passed, but the result suggests the theory is of little importance, right? So therefore, how big is still passed, and therefore, if the variance is high in this, if there's a high like this, but this is even higher, then that's high in significance. If it's higher here and high here, but it's not that it's like I said, only a little higher than the test is of little importance. Now, case selection follows John Stuart Mill's methods of difference or methods of agreement. So therefore, this case selection process looks at this idea of controlled comparisons have two different approaches. Methods that divide between controlled comparisons that deal with methods of difference or methods of agreement. In methods of difference, the investigator chooses cases with similar general characteristics and different values on the study variable, whose variable who causes the effect, whose causes or effects we seek to establish. Right? In other words, we look at everything has the same background. In other words, we look at general characteristics. In other words, choose cases with the similar general characteristics, but the value and the study variable, the values are different, right? And the study variable is the variable whose causes or effects we seek to establish. If we seek to establish the causes of the study variable, the investigator then asks if the values on the study variable corresponds across cases with values on variables that defined its possible causes, right? In other words, if we seek to establish the causes of the study variable, right, the investigator then asks if values on the study variable correspond across cases with values on variables that define its possible causes, right? What are the things that possible causes? Do we see agreement here? There's something happening here that causes there, right? If we seek to establish the effect of the study variable, the investigator asks if the values correspond across cases with values on variables that define its possible effects. Again, so if we seek to establish causes, that's one thing, right? But we can see if we seek to establish the effects of the study variable, the investigator asks if the values correspond across cases with values on variables that define its possible effects. In other words, this, again, this is agents of cause and things being affected. So therefore, the first thing is, first case, we would look at what? We'll look at the possible causal. The first case, we'll look at the possible we call the variation on the things possibly causing, and then we'll look at the variation of things possibly being affected by. Right? This is the difference here. So if we're seeking to establish causes of the study variable, we look at the things that are possibly causing something. If we're looking at something that is affected, is a dependent variable in that sense, then we know if it's this case, we read the study dependent variable. Here is we're looking at the study variable is the independent variable, and we're looking at what it's affecting, right? How is it affecting it, right? What is it doing? We're looking at what is it? If we're checking the effect of this, the best going to ask, in other words, like this. In each instance, similar cases are picked to control for the effect of third variables. The more similar the cases, the less likely that the action of a third variable explains past tests. In other words, the more similar things, then therefore they pass the test. Therefore, no third variable is the reason for this, right? In methods of agreement, that's methods of difference. Method of agreement, the investigator chooses cases with different characteristics and similar values on the study variable. So therefore, they look at the words that the case is different, but the values on the study variable are similar. Right? The investigator then asks if the values on the study variable correspond across cases with values on variables that define its possible effect, or its courses if we seek to establish these. So either we see whether we study, ask if the values on the study variable correspond across cases, the cases we're looking at, with on variables that define its possible causes or its possible effects. So therefore, we're looking at the values are similar, but the cases backgrounds are different, right? So that's we find methods of differences. We look for difference among the similar things, and methods of agreement. We look for similar things under things that are different, right? Controlled comparison is the most familiar case study method, but it's also the weakest. The method of difference is weak because in social science, the characteristics of paired cases are never really identical as methods of difference requires. The method of agreement is even weaker because paired cases usually deviate even further from having wholly different characteristics as methods of agreement require. Now, this is noting these and other difficulties with controlled comparisons are George and McNone's case studies and theories, and Stanley Lieberson's small n and big conclusions, an examination of reasoning comparative studies on the basis of small cases and social forces, right? Again, this is the criticisms of this, right? So this is the limits of this. This is what this is how we do it, but it's the weakest of those types of tests, the type of testing in this sense. Congruence procedures. When using congruence procedures, the investigator explores the cases looking for congruence or incongruence between values observed on the independent and dependent variables and the values predicted by the test hypothesis. So therefore, the test hypothesis look at the values of the independent and dependent variable. Two types of congruent procedures are used. There's two types, right? 22, he says, on congruence procedures, he says, see, George, the causal nexus between cognitive belief and decision making, right? He says, go see George on this to understand what this means further, if you want further understanding. But of the two types of procedures here, in other words, let's explain this. It explores cases of congruence or congruence between the values observed, the values that we're looking at observed on the independent dependent variables and the values predicted by the test hypothesis. What does the test hypothesis predict? And then looking at this to see if there's a congruence between everything or incongruence between it, right? Congruence shows validity and incongruence shows invalidity, right? Congruence procedure type 1, comparison to typical values, right? This is congruence procedure type 1, this is the type 1, and the comparison to typical values is a description of it. The investigator observed values on the independent and dependent variable within a particular case and observes the world without doing further case studies to ascertain values in the IV and the DV that are typical in most other cases, right? So therefore, look at the world, look at the observation of the world. The world of the by the world is the world of the environment of the universe that this case is of a case of. Not doing any more case studies, just looking at the larger world. He says, so therefore what we do is what? We investigate the values on the IV in the particular case and observe the world to do what? To ascertain the values on the IV that are typical in most other things, right? The investigator then deduces from these observations and from the test theory expected values on the IV and DV in this case study and measure the congruence or incongruence between expectation and observation. So again, so you look at the world, you observe the values on the IV and DV in the case study, observe the world, how they do it. You ascertain what are the typical outcomes of those things and the wider world of the situation you're addressing, and then you do is what you look for. You test. In other words, you investigated and deduced from these observations, from the test theory, relative values of this, and measure the congruence and congruence between the expectation of what you expect and what the observation shows. The example in the given case, if the IV value is above the typical norm, the value on the dependent variable, in other words, for example, in a given case, if the independent variable's value is above the typical norm, the value on the DV should also be above the norm if the theory holds water. Okay, congruence procedures. See this Alexander George's causal nexus thing again, repeating this. So therefore, what should happen is that if these look at your values, what is the normal value of the IVs about all these things, and then what you do is then you go look at the situation. In your case, if this is above this, then it should be above the norm as well. Okay, if this is above the norm, then the outcome should be above the norm if the value holds water, right? Theory holds water. If values on the dependent variable, in fact, are above normal, the theory passes the test. If they are far above normal, this indicates that theory has large importance, that the variance on the value in the IV will cause large variance on the DV. If they're only a little above normal, the test is again passed, but the results suggest that the theory has little importance. So again, if, in other words, if they're above normal, but if they're very above normal, the dependent variable is very above normal, then it's high importance. But if it's slightly above normal, in other words, if it's significantly above normal, okay. But if it's just a little bit, then it's less significant, right? We have to look at the degree of variance, and that's how you test something that is not it's above it, but not as above it as you'd expect it to be, right? Versus expecting it significantly beyond where it's way above normal. It's like, and in statistics, we usually say um, um, a typical deviation, which is standard deviation discussions, which is standard deviation is one clear distance block between one a point a thing, something that's within the standard deviation, but it's above it, but a little still not a complete standard deviation. That would not necessarily be, but something that is a clearly standard deviation that is, uh, um, uh, um, in other words, something that is at least one or two standard deviations from the what's expected is usually considered significant, right? So therefore, that's the idea in that sense. This is why we talk about this in that way. Now he goes, thus, to test the hypothesis that economic downturns causes scapegoating of ethnic minorities. So that's the hypothesis. Economic downturns causes scapegoating of minorities. We could explore cases of downturns, such as the United States during the Great Depression in the 1930s, asking if ethnic scapegoating was above normal in these cases, or we could explore cases of prosperity, the United States in the 1960s, and ask if ethnic scapegoating was below normal. So you can look at cases. We can do it this way. What is the level of look at the nation of scapegoating? What is the average of the normal level? And then what we see is in a high time of economic prosperity, we should see less scapegoat. The theory is economic downturns cause the scapegoating of this. We should see as the worse economic conditions, more scapegoating. Better economic conditions, less scapegoating, right? So therefore, in better economic terms, the percentage of the activity of scapegoating should be below normal. In bad economic terms, that should be above normal. That's how we can test this theory out. How we ascertain normal IV and D? In other words, how do we ascertain normal IV and D values? Often, the normal background levels of phenomena are matters of common knowledge, right? Thus, we know that the United States economies of the 30s was more depressed than typical modern industrial economies, without doing new studies to prove it. We know that Nazi Germany and Stalin's Soviet Union was more murderous than typical modern industrial states, and we can safely compare their conduct to this typical conduct in a case study. We know that elite belief that conquest was feasible was according to historical average in the 1914. If common knowledge is thin or unreliable, however, research to establish a typical values is necessary. So if you don't have in other words, common knowledge, and now the question is, in actually research, this is why some people say you don't have to cite common knowledge. I think if you're going to assert something as common, if you're claiming something is common knowledge, then maybe giving evidence that shows that is valid, that statement is valid, is useful. Okay, so this was so when the argument is I don't need to say that's common knowledge. Well, maybe you should give support that someone who can say, well, how do you think? Give some evidence for this that is common knowledge. And giving evidence. Now, what kind of evidence? Well, general histories, one or two general histories that support that theory would do fine. Avoid encyclopedias and Wikipedia because these are not necessarily good sources in that sense. They're not trustworthy. Wikipedia is the least trustworthy. Even though some things are good on, some things they're useful to do, they can get a good understanding. They're very manipulated by the people who have authority to edit it now, and usually they have agendas and they alter this. Same thing with encyclopedias today. I trust more older encyclopedias and social science. Things before the 1970s are more trustworthy than things 1980s, 1990s onwards. Okay, so you shouldn't really rely on encyclopedias. You should go to more authoritative sources, his general histories and like even textbooks. In this case, citing textbooks would be okay, even though textbooks are not as good valid. So what do we say here? Now, so therefore, congruence procedures type 1 works best if we select cases with extreme high or low values on the study variable. Right? The study variable is the variable we study. It could be whatever. It could be the IV, the EV, or the intermediate variable, right? Or even whatever it is. That should be high or low. It works best. Congruence procedures type 1 works best when they're very high or very low, right? Thus, to test hypothesis that economic downturns cause scapegoating of ethnic minorities, we should explore United States in the 1930s of extreme downturn instead of a lesser U.S. or European recession. To test the hypothesis that belief that conquest is easier causes war, we should explore Europe between 1910 and 1914, when such beliefs were unusually widespread instead of more normal cases, right? An example from physics is found in the test of Einstein's general theory of relativity, conducted with photographs of May 29, 1919, the solar eclipse. Einstein's theory predicted that gravity would bend the path of light. Accordingly, scientists looked to the strongest gravity sources that they could find, the sun, and asked if it could bend the path of light. Photographs of the ellipse view were used because it, in darkness, made stars near the sun visible, letting scientists observe if these stars appeared displaced by gravity. In other words, scientists selected a case where the value on the IV, independent variable gravity, was as high as possible. On this test, see the discussion on process tracing in this section, right? So therefore, this is an idea. This sense. Cases that exhibit extreme values on the study variable are good test laboratories because theories make more unique and certain predictions about them. So therefore, in other words, these extreme values on the study variable make good because they make you more unique and more certain predictions. The stronger the certainty, so you can do this, that's the better test, right? This allows stronger tests. In a case where a theory's causal phenomenon is extremely abundant, its effects, according both to its intervening independent variable, should also be abundant. Likewise, if the cause is unduly scarce, its effect should also be scarce, right? If we observe those extreme results, it is unlikely that they arise from measured error, since only a large error would cause the observed result. Right, so we see that these things are like this, and therefore it's not error. It's because only in other words, unlikely that error that would be that extreme result. The action of a third variable is also unlikely to cause the observation, since it is unlikely that another cause operates strongly enough to produce that striking effect that the theory predicts. So therefore, eliminating third variables. In other words, you see an extreme effect, you see something that's more extreme than is normal, you get the same outcome in that thing. It's going to be, the argument is that it's a theory, not an error, and not a third variable, right? These would be highly unlikely. Produce the striking effect that the theory predicts. Then, in any third variable that was responsible would also be abundant, hence it would stand out against the case background, making it easy to spot. So if there was that thing like that, it would be easy to spot there. Okay, there is a third variable there. Hence, we can more easily rule out measurement error and omitted variable explanations for past tests. In other words, the test prediction is quite unique, hence the test is strong. So it's both certain and strong. If we fail to observe the predicted test, it is less likely that measurement error and countervailing effect of other variables caused the failure. Since a large result was predicted, the result should have overpowered any measurement error or countervailing variable appearing in spite of them. A countervailing variable would probably be needed and abundant, and hence easy to spot. Hence, a test failure in the absence of a visible, powerful countervailing variable casts large doubt on the theory. In other words, the tested prediction is quite certain. Hence, the test is strong. So it's both unique and it is certain. This is, again, remember back to our importance about strong tests and weak tests, right? Let's go now. Continue here. Hence, both passing and flunking of tests provide decisive evidence in case of extreme values on the study variable. Passage strongly collaborates the hypothesis. A flunk strongly infirms it. So therefore, double decisive. Right. This is why this kind of thing is very useful in that sense. Congruence procedure type 1 is a close cousin of controlled comparison. Both rest on comparisons across cases, not within them. Now, George describes congruence procedures, and by which he means type 1, as within case studies, because he argues that congruence or incongruence is established by deduction, not by comparison to typical values in other cases. Specifically, he argues that once we know the values on the IV, we can deduce the expected values of the DV from the test theory. Then we assess the congruence or incongruence of this expectation with the observed values. He admits the idea that the expected within case DV values are instead established by comparison to typical IV and DV values. Right? However, it seems to me that any such deductive exercise must rest on comparison to typical values in other cases and the expectation about the study cases that are calculated to these typical values. Hence, it relies on cross-case comparison. I think he's right. This is why George ignored. I think this is why I like Evera in that sense. He's clear, he's concise, and he's brutally honest. Right. So, as a close cousin, both rest on cross comparisons with not within them. Both offer means to reduce the possibility that past tests resulting from the action of a third variable. They differ in the method of reducing this possibility. Right? They are similar in that past tests result in the actions they reduce the possibility that a past test results from a third variability, but they differ in that the method of reducing that possibility. Right? Controlled comparisons hold the case background constant, thus preventing the variance of potentially perturbing third values. Thus, it narrows the range of values that vary across cases, which lowers the number of potential perturbing variables. Right. In other words, this reduces the number of possible variables they're doing. In contrast, if the extreme value on the study variable case selection is used, congruence type 1 reduces omitted variable problems by expanding the impact that omitted variables must generate to produce the result predicted by the theory. This lowers the likelihood that any third variable have enough impact to produce this result, and thus ensures that these variable necessitates extreme values will call attention to themselves if they do not. If they do, in other words, they would call attention. In other words, if there is a third variable, they would call attention to themselves, right? If they did do this. Thus, the number of potential perturbing variables is reduced again, this time by a different method. So, therefore, this is, even though these are similar, this way does it by a completely different method, controlled comparisons, and it's congruence procedures than controlled comparisons. Because why? It does it by the showing of how the effect of this, and that the effect would then be liable, rather than merely trying to limit it. Okay. Now, the second congruence type 2, congruence procedure type 2, multiple within case comparison. The investigator makes a number of paired observation of values on the independent and dependent variable across a range of circumstances within a case. In other words, it's within the same case. This case, the n. N, remember, n means n1 is a case, number of cases. High N means lots of cases. Case study, one single cases, N1. N equals 1. And therefore, within a case, there's going to be the range of circumstances. In other words, we're looking at, what is he saying? The paired of observation of values on the independent variable and dependent across the range of circumstances of this. When the investigator assesses whether these values Covari come together, in accordance with the prediction, I love this word Covari. It means that let me get precise here because I don't want to be imprecise. Okay, I say Covari, I mean Covari. Sorry. These values covary in accordance with the predictions of the test hypothesis. If they covary, the test is passed. The greater the aptitude of the dependent variable's covariance with the IV, the greater is the theory's importance. In other words, so what does this mean? This idea of covary means that they kind of correlate and they have they come together and they to covary means that they come together and they follow the same pattern, right? So if they covey, the test is passed. If the amplitude of the the amount of the dV's covariance with the IV is greater, in other words, the greater the amplitude of the dV's covariance with it, uh, 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 with the IV, the theory, the greater the theory importance. In other words, so therefore. Yeah, okay. This is where I wish I had. I wish this was on there. We have a dictionary, pop it up. There's no dictionary here, unfortunately. Um, but covary means the degree that something varies, changes, right? Something changes. So this is co means together change. So if the effects here is that if there's a change here, there's a change here, right? And here that he's saying that the effect, he says, if the covariant effects, if they do covey, if the effect says that this the independent variable says there's going to be a variation, they are both variating to the degree that the theory says they should vary, then the test uh, 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 is passing. But if they're not doing it, the opposite. He says if the greater amplitude of the dV, the dependent variable, is more on the dependent variable covariance with the IV. There's greater amplitude on this. The variance here should be variance here, and this is much greater than here. Then it's the greater theory importance. Thus, to test the theory that economic downturns cause scapegoating with ethnic minorities, we might ask whether periodic measures of scapegoating are possible at timed intervals during the Great Depression, and ask that during 1929 to 1941 are, as we might ask whether scapegoating increases as the Depression deepened during 1929 1933, and whether scapegoating eased when the Depression later eased, right? So therefore, we should see when the period of increasing, getting worse, we should be seeing if badder economic times lead to more scapegoating. Therefore, this period we should see as that time gets worse, we should see an increasing scapegoating. But when the time was getting better, we should see a decreasing scapegoating. Right? That's the should be the situation. Congruence procedure type 2 works best if we select cases with two characteristics. One, many observations on the many observation of values on the independent variable and dependent variable are possible. So you can have many things that observe many observations on the values on the independent or dependent variable. And or two, that's one thing. The second way is that values on the independent variable or dependent variable vary sharply over time or across space, across region, institution, group, or subclass within the case. So that this type 2 works with these two characteristics. One, that we had many observation on the values on the IV or DV are possible, or that two, that values of this independent variable vary sharply over time or space within the same case. Case allowing many observations are better test laboratories because they allow more measures of congruence, and tests that results on more measures are stronger, right? So therefore, in other words, the case allowing many observations. So this one is, strong, are better because they are stronger. Because they are better test laboratories because they allow more measures. He says, cases with large variation on IV or DV are also good test laboratories because theories make more unique and certain predictions about these cases. So therefore, this is better because why? Because we have more tests. Here we have tests that are more unique and more certain about these cases. Prediction, in other words, because theories make more unique and certain predictions about these cases. For example, if values on the theory's IV are sharp, values on the DV should also vary sharply. This sharp variance on the DV, dependent variable, is unlikely to arise from measurement error, and since the error would need be large to gyrate in step with the independent variable, an unlikely combination. This is an unlikely combination, right? So therefore, you'd have to have a thing that's so huge, a measurement, an error that have to be so large as to gyrate in step with the IV. That's really noticeable, right? The action of a third variable is also an unlikely cause, since this would require a third variable that gyrates in step with A and an independent variable, and as markedly as A, the independent variable, and an unlikely possibility, and one that is easily assessed since such a variable will leap out from the case, right? It'll be obvious that such a thing's happening. It's going to be a third variable doing this. You can have. Hence, we can more easily rule out measurement error and omitted variable explanations for past tests. For parallel reasons, we can rule out these. For parallel reasons, we can rule out these explanations for failed tests. As a result of both the passage and flunking of the test provides decisive evidence in cases of sharp variance on the IV. Partially strong collaboration with a passage of the test. This test strongly corroborates the hypothesis. Failure strongly affirms. This is again double decisive in a sense. Congruence type procedure 2 within case studies. Congruence procedure type 2 is within case studies, but it casts into a large N analysis. It casts shades into a large N analysis at some point as the number of within case observations grow larger and the values on the variable are assigned metric values, right? In other words, we get so many, we either have so many cases, the number of sub things, variables we're dealing with. In other words, the number of within case observations grow larger and the values on these variables are given certain values, right? This is why it looks like a large N stuff. For example, the 1994 election is a bounded example of something more general, a parliamentary election in a democracy. Hence, it has aspects of a case. It also allows hundreds of observations expressed in numeric form. For example, the 435 U.S. House races. These can be studied and statistically compared. Such a study has aspects of congruence procedure type 2 and large N analysis. So therefore, this is an example of something that is both within a type 2 cross a type 2 thing, but it's also kind of like a large N because the number of cases, number of things, 435 house races, right? Case studies should, in principle, be hybrid of congruence procedures type 1 and type 2. So case studies, in principle, shouldn't be hybrids of these type 1s and type 2s. Analysis could be made, an analyst could make many observations of a case and compare those observations both to each other and to typical values. An analyst, political scientist, could also select cases that offer many observations on the independent variable and dependent variable, on extreme values on the independent variable, dependent variable, and large variance on these variables, all at the same time. In other words, we can do off many observations of IV and DV, extreme values on the IV and DV, and large variance on these, all at the same time. Both types of congruent procedures can be used to test theory's explanatory, in other words, theory's explanatory hypothesis as well as its prime hypothesis. In other words, example, if we hold that if a theory holds that A causes small q causes B, then A causes B is the prime hypothesis. A causes Q and Q causes B are the exploratory hypothesis. See, you guys go see what a theory is, right? So therefore, we can test not only the main hypothesis, A B, but also A this and this, but also this as well, right? No, but this and this. So we can, in other words, test the theory's explanatory part as well as its prime. To test explanatory hypotheses, we prefer cases that permit multiple measurements and uh, and or display extreme or sharply varying values on either or both variables in the tested explanatory hypothesis. So therefore, in other words, on either or both variables of this, right? Um, and therefore that's why we prefer, in other words, to test this hypothesis, we prefer not only multiple measures of and display of extreme or sharply varying values on either or both variables of this hypothesis. Now, that ends our discussion of both congruence procedures, both type 1 and type 2, and why even you do, you should all, and you should be doing, actually you should be good, all case studies really should be doing both type 1 and type 2 things in them, in that sense. Now we get just to process tracing. 28, this is, he says that, talking to McGraw and Greggs in this. In process tracing, the investigator explores the chain of events or the change of decision-making process by which initial case conditions are translated into case outcomes. Chain of events, historical events, or the process. In other words, the chain of events, the process, either of events or decisions that are made, right? The cause-effect link that connects independent variables and outcomes are unwrapped and divided into smaller steps. Then the investigator looks for observable evidence of each step. Okay, so therefore we see. In other words, we look at a thing. We look at this, how this process. We divide it. How does this happen? What are the steps that the process? The steps of the process of this thing causing this thing. We look at this process. Now he says, for example, if asteroid impacts cause mass extinctions, we should find evidence from asteroid causing mass killing mechanisms in sedimentary records of mass extinction that coincide with asteroid impacts. Perhaps an impact would kill by spraying the world with molten lava, igniting global forest fires that blacken the skies and smoke, shutting out sunlight and freezing the earth. If so, the sedimentary record of mass extinction should contain the remains of vast continental or global molten rock showers, or a layer of soot and evidence of mass dying of species, evidence of each step in the killing process, right? 29. Evidence of the sedimentary record right down to the time of the dinosaurs' demise 65 million years ago also coincided with an asteroid impact, confirms of these predictions. This is that Evera and Averos, right? The Scientific American, 1990. In the selection of how scientific experiments can be explained, in Chapter 1, I noted that the same evidence could be used to test an explanation for a specific event. The impact of the theories dinosaur. This illustrates that the same evidence can test both general theories and specific explanations, right? This is good. This is his example of this, right? This test specific information. This is what, in many ways, this is what process tracing does. It kind of gives us the general explanation, right? Likewise, if bipolar disruptions of interstellar power causes peace, we should find, in cases of a peaceful bipolarity, evidence of intervening phenomena that forms the causal changes by which bipolarity causes peace. Right. This is the theory. If bipolarity causes international power causes peace, we should find what evidence of intervening phenomena that forms the causal change by which bipolarity forms peace. Kevin Waltz, the prime exponent of peacefulness by bipolarity, suggests that bipolarity causes the following pacifying phenomena: less false optimism by governments about the relative power of opponents, easy cooperation and faster learning by each side about the other, and leading to thicker rules of the game. Faster and more efficient internal and external moves by each side to balance growth in the other's power or to check the other's aggressive moves, causing deterrence, and the selection of fewer inept national political leaders. Number 30. Waltz. My list of Holt's hypotheses is incomplete. For the rest, see a bit in that sense that this book. He lists that Waltz's theory of international politics, right? He gives it some 161 to 176. He has a whole list of things, right? A process test would look for evidence of these phenomena in cases of bipolarity. For example, the Cold War, 1947-1989, and if they are found for evidence, they should stymie. They should and for evidence that they stem from bipolarity. For example, testimony by policymakers that reveal motives and perceptions may fit this interpretation, right? So therefore, you look for evidence in the record. You look for evidence of such things in the record, and this idea of this. You look at the process of this. Evidence that a given stimulus causes a given response can be sought in the sequence and structure of events, and or in the testimony of actors explaining why they did what they did. For example, if commercial competition causes war, case studies of outbreaks of war should reveal pressures for war on commercially interested elites. Government decisions for war should follow, not precede this pressure. And statements in the diary, private correspondence, or memoirs, and so on of government officials should indicate that government decisions reflected this pressure. If public relation campaigns shape public opinion, shifts in public opinion should follow public relation campaigns. And interviews with citizens should reveal that they absorbed the campaign message and changed their views about it. So this is explaining how this process tracing, different ways of process tracing, right? This is a case where you say, well, wait a minute, diaries of this, aren't diaries not necessarily evidence? Well, this is the case. We're looking at the decision makers of this. So the thing that you're looking at is what were the ideas or values of the decision maker. Well, these are his memories of it, his diaries, and diaries are live things usually. So they're not necessarily things that you can test like this, but they can be tested to the question of what decision. These are decision maker. He's evidence of this. We look for other decision makers to see if they similarly had that. So this is finding one guy who did it. You have to find like dozens of people who similarly have. Of the decision makers, look for a number of them, and all those. In other words, the argument, but isn't that truly a representative sample? Sometimes some data you don't get huge. If you go look at the sample of the available sources that have records of this, you check them as possible, and then what you do is then you say, okay, this is happening, right? But if a significant number of say it doesn't happening, okay, then you can say that. In other words, that's how we understand this. This is how this works. That's how certain things can be used as evidence in a sense. Process predictions are often unique. No other theories predicts the same pattern of events or the same actor's testimony on their motives. Hence, process tracing often offers strong tests of the theory, right? In other words, process tracing often provides smoking gun tests. See the section strong, weak tests in chapter 1, right? Hence, a thorough process trace for a single case provides a strong test of a theory. As noted above, an investigator will still be unsure what antecedent condition the theory may require to operate, and discovering these conditions might remain an important task. They can be found only by exploring other cases. Still, the validity of the theory and the ability to explain at least one case are strongly corroborated. Theories assume many causal patterns, and we can adapt process tracing to fit these patterns. Some theories, such as, for example, asteroid impact theory of explanation, posit a single chain of events, right? A causes P, small p causes small q, causes R causes big B, right? Independent variable, intermediate variables, right? This is the impact of this, right? Some Waltz's polarity theory posits several chains. A causes either P, Q, or R, which then causes B. P, Q, or R then causes B, right? A complete process trace looks for evidence of all links in all the chains. So therefore, links of all the chains. A complete process trace would look at how this works and how this produces this effect. A complete process looks for evidence of all links in this chain. Right? Case studies can assume several or all of these four formats: controlled comparisons, type 1, type 2, and process tracing at once. So therefore, in other words, the case study can assume all four of these things. Aspects of controlled comparisons, congruence type 1, congruence type 2, and process tracing all at once. And in the same study, we can compare a single case to another case chosen according to Mill's methods of difference or the typical conditions. We can examine it to see if within case measures on the values of the IV and DV Covari over time and space, and we can study it for evidence that collaborates or infirms the theory's explanatory hypothesis. Right? That's doing all four. How strong are these? How strong are the tests? How strong are theory tests in case? Sorry. How strong are theory tests that case studies propose? Scientists tested Albert Einstein's general theory of relativity with a single real-time congruence procedure type 1 case study. The observation of May 29, 1919 solar eclipse, Einstein theory predicted that gravity would bend the path of light towards the gravity source of a specific amount. Hence, it predicted that during a solar eclipse, stars near the sun would be slightly displaced. Stars actually behind the sun would appear next to it. And stars lying next to the star would appear further away from it. And it predicted the amount of apparent displacement. No other theory made these predictions. The passage of this one single case study test brought the theory wide acceptance because the test predictions were unique, as there was no plausible competing explanation for the predicted results. Hence, the pass was also very strong. 32. A synopsis of these events is found in Albert Einstein's Relativity, right? Scientists concluded this case study in real time, studying the ellipse as it occurred. But they could just as well study a past ellipse if one had been photographed showing the positions of whereby star during ellipse. Another decisive real-time case studies from physics, also congruence procedure type 1, is the observations of the return of Halley comet in 1758-59, which powerfully supported Isaac Newton's theory of gravity. In 1705, astronomer Edmund Halley applied Newton's theory to predict the comet's return in 1758 and 59. It appeared almost exactly on schedule. Right? This is the Romans' history of chronology of history observations, myths, and folklore. Opponents of Newton's theories were silenced when this and other real-time single case studies tests, the 1737 measurement of the flattening of the Earth, confirmed Newton's theories beyond a shadow of a doubt. This is from Livy's Solar System, Renault, and Beyond the Beginning of Modern Science. So, like this, right? He says, um, any case study that reliably tests equally unique predictions can offer you equally decisive results. Social science case studies will seldom be so decisive, but this problem stems from the messy nature of social science data and the complexity of social phenomena, not the inherent weaknesses of case studies. So again, this is why this is the problem. It's messiness, and therefore we're not going to get the decisiveness, but we can still have case studies are still effective. It's again, social science has a problem. The what do you call the messiness of social science data and the complexity of social phenomena is the problem, in why case studies are kind of a thing, and that's going to affect also the probability of large n studies, and also express why experiments can't be used. So therefore, this is not uniquely to case studies, but these two factors affect all social science. Here we end. We stop. I think we're at a good point to stop. Um, we'll look at next. We'll look at the remainder, creating theories, and then also antecedent conditions, creating and testing antecedent conditions. Um, so we'll stop here, okay? And any questions or comments, please put them below, and once I see them, I'll do them. If you liked it, like it, hit the like button, share it with a friend, share it on your social media. If you didn't like it, say why. Say why in the comments you didn't like it. In that sense, maybe I can learn. Maybe I did something wrong or something. So you got the word wrong. I caught myself getting the word wrong. I always sometimes mispronounce those words because I look at it and I see it that way. I don't see a verb. I just miss something. The You've not subscribed. Subscribe. Get others to subscribe. I hope you get notifications that this new videos are available. Um, you can follow me on social media, links below. You can follow me in academic social media, more about my research, links below. If you want to help me to do what I do, you can do so by subscribing to our Patreon, links below. Or you can buy one of my books mentioned below at one of the online bookstores. Or if you want to if you buy my Lulu book by Lulu, I'll get the money what the bookstores get. So that is it. I hope you all have a good day. We will look next when we talk about case studies. We finish the next chapter next time on this. We'll take care and have a good day. Bye bye.